Hi everyone, my name is Arvinichi, and today I will continue with the start of private network part 2. In the previous video, you create the local node with the account Alice and Bob, and we interact it with the Polkadot.js Explorer and the local node. And today's video will continue with the generate your own keys, and you can make your own node. Now that you know how to start to connect running nodes at peers using command line options, you are ready to generate your own secret keys instead of using the predefined account keys. It's important to remember that each participant in the blockchain network is responsible for generating unique keys. Now we go to the key generation options. There are several ways you can generate keys. For example, you can generate key pairs using the node template subcommand and standard alone subkey command line program, the Polkadot.js application, or the third-party key generation utilities. Although you could use predefined keys pairs to complete this tutorial, you would never use those keys in the production environment. Instead of using the predefined keys or the more secure subkey program, this tutorial illustrates how to generate keys locally using the subtree node template and the key subcommand. Generate local keys using the node template. You have already used some command line options to start the local node blockchain node using the predefined Alice and Bob accounts. You can also use command line options to generate random keys to use with substrate. As a best practice, you should use the air-gapped computer that has never been connected to the internet when you generate keys for the production blockchain. At the minimum, you should disconnect from the internet before you generate any keys you intend to use a public or private blockchain that is not under your control. For this tutorial, however, you can use node template key subcommand to generate random keys locally and can remain connected to the internet. To generate key using the node template, the step 1, you open the terminal shell on your computer. And now you can change the root directory where you compile the subtree node template. I will go to this folder by typing the cd subtree node template. Now we will generate the random secret phrase and keys by running the following command. I will copy it and paste here. So I will type my password. Now you can see some information about the stream SR25519. Now at first you can see the secret phrase, and we use this for the create the new node using the key SR25519, and we have a network ID and secret. You can use this secret or use the secret trace, and you have a public keys and account ID, public key in the SSI 8 and SSI 8 address. Yeah, now you can see the SR25519 key for the producing blocks using our for one node. And in this example, the SR25519 public key for the account is, yeah, you can see this public key, and you can use the secret phrase for the account you just generate to derive keys using the ED25519 signature string. For example, running commands similar to the following. You can see you use the secret phrase. Now you can type password, yeah, and the command display output similar to following. Yeah, I will try it. We'll copy and go to the command line. Now I will make a text. Okay, go to the text editor. So now I will paste it here and replace the secret phrase by my secret phrase here. Okay, I will try it. Yeah. So I will copy it and run. We'll try it. Yeah. Okay, you will place here. And I will try it again. It's not running here. Okay, I will test this in the future. Now we will next to my study. Okay, it's not running here. Yeah. So we'll see the command display output similar. Okay, you now have the ED25519 key for the finalizing blocks using the grandpa for one node. In this example, the ED255 public key for the account. What? The grandpa, we will just create a array. Wait, something like that here. So I will copy it. Fine. Okay. This code for the 825519 for the grandpa. Yeah. Okay, I will copy some information of this. Copy. And go to my node. Yeah. I will. That is the our for one node. And we have a grandpa for one node. We'll copy that. Copy this. Okay. We'll go and paste here. And so we will go to the generate a second set of keys. For this tutorial, the private network consists of just two nodes, so you need two sets of keys. You have a few options to continue the tutorial. You can use the key for the one of the predefined accounts. You can repeat the step in the previous section using a different identity on your local computer to generate a second key pair. And you can derive the tri-key pair to simulate a second identity on your local node computer. You can recruit other participants to generate the keys required to join your private network. For illustration purposes, the second set of keys used in this tutorial are the SR25519 for our and 825519 for grandpa. You can see that keys. That's key. Okay, I will some similar thing in that code. Now we create a custom chain specification. After you generate the keys to use with the blockchain, you are ready to create a custom chain specification using those key pairs. Then share your custom chain specification with Trust Network participants called validators to enable other participants in your blockchain network. You should ensure that they are generate their own keys. If other participants have generated key pairs, you can create a custom chain specification to replace the local chain specification that you used previously. This tutorial illustrates how to create two-node network. You can follow the same steps to add more nodes to your network. And next, we will modify existing chain specification. Previously, you added a node to the blockchain using the predefined local train specification using the train local command line option. Instead of writing the completely new train specification, you can modify the one that you have used before. To create a new train specification based on the existing specification, at first you open the terminal shell on your computer and change the directory where you compiled the subtrainer template. So we will copy that following code to export the local train specification, name the custom specification, running this. Paste here. Okay, this building train spec. And if you open the custom specification file in the text editor, you will see that it contains several fields, including a large block that contains one binary for runtime you built in using the cargo build release command. Instead of viewing the entire file, you can review the first and last two lines. To see the field you need to change. Now we preview the first few lines in the custom specification by running the following command. Okay, this will read the file custom spec. You can see the name, ID, train type, boot notes, chemistry endpoints, protocol ID, and properties, code substitutes, and genesis. So you can preview the last fields in the custom specification file running this command. Okay, it's so long code. You can see the balances, grandpa, hour, and the long keys. Oh, I don't know how long that is. So okay, as you can see, it's a system code. In this command displays class sections following the one binary flow, including the details for the several palettes such as the pseudo and balances values that are used in the runtime. Now we open the custom specification file in the text editor. Okay, we'll open it by the custom Visual Studio Code. Here you can see the custom specification. It's too long code. Okay. Now you can modify the name if you identify this train specification as a custom train specification. For example, you can change that name. Irving Testnet. And you can modify Aura field to specify nodes with the authority to create the blocks by adding the SR25519 and SS58 address key for each network participant. Okay, so long I will drag it to the Aura. Yeah, this Aura. And you can see two keys here. Okay, I will look back the Aura information, and you can see the LS58 S58 address here, and we will copy it, yeah, and replace it. Okay, and you can use some key of the Aura and Grandpa. Now use the SR255 for Aura and copy it for Grandpa. So, looking back here, and you can see some information about this line. So this is the second key here. You can see. Okay, I will copy it. And the keys here, you can see. I will copy it here. Yeah, you can see the 5CFB, and the last one is the handicap and W here. Now we will replace this with this code. Yeah, we'll replace it with this code here. Now we will do the same thing with the WAN card. Copy this code here. And copy this code here. Okay, I will save this file. Okay, save the changes and close the file. So, and next we will add the validators. As you have just seen, you can add the change authority addresses in the train specification by modifying the hour and grandpa sections. You can use this technique to add as many validators as you like. To add validators, modify the hour section, include the SRN25519 addresses, and modify the grandpa section to include the EDs 25519 addresses and voting weight. Be sure to use unique keys for each validators. If two validators have the same keys, they produce conflicting blocks. For additional information about working with the key pairs and signatures, see the public key cryptography. Now you can convert the train specification to use the raw format. After you prepare the train specification with the information you want to use, you must convert it into the raw specification before it can be used. The raw train specification including the same information as the unconverted specification. However, the raw train specification also contains encoded storage keys that the node uses to reference the data in its local storage. Distributing a raw train specification ensures that each node stores the data using proper storage keys. To convert the train specification to use the raw format, you need to open the terminal. You can make clear. Okay, we will go to the folder and convert the custom specification train specification by raw format with the findings of this custom spec raw version. Okay, I will copy this command and paste here in one. Now you can share the train specification with others. If you are creating a private blockchain network to share with other participants, ensure that only one person creates the train specification and shares the resulting raw version of that specification. For example, the custom spec raw station file with all of other validators in the network. Before the compiler produces optimized WebAssembly binaries that aren't deterministically reproducible, each person who generates the runtime produces a slightly different worm block. To ensure determinism, all participants in the blockchain network must use exactly the same raw train specification file. For more information about these issues, you can see the hunting down the non-determining bug in our Rust worm build. Okay, we'll go to the private network. After you distribute the custom train specification to all network participants, you are ready to launch your own private network blockchain. The steps are similar to the steps you followed in the start blockchain, using predefined accounts. If you follow the steps in this tutorial, however, you can add multiple computers to your network. Multiple computers. Okay, to continue, verify the following. You have a generate or corrected the account keys for the at least 2 authority accounts, and you have updated your custom train specification to include the keys for block production, power, and block finalization rank. You have converted your custom train specification to raw format and distribute the raw train specification to the participant in the private network. If you have completed this step, you are ready to start the first node in the private network blockchain. Now we will start the first node. As the first participant in the private blockchain network, you are responsible for starting the first node, called the boot node. To start the first node, open the terminal shell on your computer and start the first node using the custom train specification by running a node command similar to the following. Okay, I will run it here. Yeah, this is my node. Okay, you can see the 0 appears because it's only one node. And following the command line options you're using to start the node, you can see the base path. This command line option specifies a custom location for the train associated with the first node. And you can see it's a trial path. And next is a train. Command line option specifies the custom train specification. You can see the RPC method unsafe. This command line option allows you to continue the tutorial using the unsafe communication mode because your blockchain is not being used in the production setting. And you can see the name. Command line option enables you to give your node a human readable name in the telemetry UI. And this command also start the node using your own keys instead of predefined accounts. Because you aren't using predefined account with known keys, you will need to add your keys to the key store in the separate step. Now you can view some information about your node operation. After you start the local node, information about the operations performed is displayed terminal shell, and it's like this. Now you can see some information about your node. You can see the output shows Genesis block being initialized with the block hash. Yeah. And the output specifies the local node identity for your node. Now you can see the local node identity is, and the output specifies the IP address used for the node is localhost. These values are for the specific tutorial example. The value will be different for your node, and you must provide the values for your node to other network participants to connect to the boot node. And you can add keys to the key store. After you start the first node, no blocks are yet produced. Yeah, you can see 0 pairs is no block. And for each node, you can add the our authority keys to enable and add the grandpa authority keys to enable block finalization. There are several ways you can insert keys into the key store. For this tutorial, you can use the key subcommand to insert the locally generated secret keys. To insert keys into the key store, you open the terminal shown on the computer, change the root directory where you compile the subtrain node template, and insert our secret key generated from the key subcommand by running the command similar to the following. Now I will copy it and have some modify. Modify the hour. As you can see the series secret seed. I will copy that here. Or you can also use the sacrifice. I will check it for you here. You can replace it. Replace it here. Okay, I will copy that. And type your password. Okay, we will insert the grandpa secret key generate from the key subcommand by running the command similar to following. Okay, I will insert grandpa, modify grandpa here, and you can copy secrecy here or the sacrifice, whatever you like. Okay, I will copy it here and run this. Now you can verify the keys are in the key store for the node 1 by running the following command. Okay, you can see some keys in the key store. Now you can enable other participants to join. You can now allow other validators to join your network using the boot nodes and validator command line options. To add the second validator to private network, you can open in the second computer. Now I will make it in the same computer because I don't have other computer. So I will change the node, the second node here. Okay, the node 2 is running, and you can see one peers here. Yeah, and at the first node you can see the one peers here. So now you can go to the Explorer. I think we will go to the custom here. So I will take some break. Okay, be sure to set the correct root node identifier in the command. If you don't set the correct root node identifier, you can see the arrow. Okay, it's no arrow here. Note that the command includes the base path and name, command line options, plus an additional validators option to specify that this node is validator for the private network. Also, note all validators must be using identical train specifications to peer. Okay, you can add the hour and security generate key subcommand by running a command similar to the following. Okay. You can see the node 2 here, and I will make for node 2. Alright. And copy that command. If you have a two computer, you need to try it. It's very interesting. Now you can modify the grandparent. Copy here. Paste. One. So now you can go to the node 2 here. And you can check the node 2 in the key store. Subtract node requires restart after inserting the grandpa keys, so must shut down and restart the node before your blocking being finalized. To shut down, you can use the Control C here, and I will restart the node 1 and start the node 2. As you can see, the one pierce that is running. You can see the block increase in the time. Here, after you both nodes have added their keys to their respective key stored local under the TMP node 1 and node 2 and being restarted, you should see the same Genesis block state with hashes. You should also see that each node has one peer and they have proposed you a block proposal. Yeah, that is block 18. Okay. After the few seconds, you should see new block being finalized on both nodes. Okay, it's all about today's lesson, and in the next steps, you have now seen how you can start a private net blockchain with trusted participants. In this tutorial, you'll learn how to start and stop peer blockchain nodes, how generate your own secret key pairs, how to create a custom chain specification that uses the keys you generated, how to add validators to private network that uses your custom chain specification. And to learn more about the topic introduced in this tutorial, you can go to this website. Okay, thank you for watching and see you in the next time.